Grade 8, we are going to continue the second part of the chapter of the chemical bonding. We have already ended the part related to the ionic bond. Now we are going to explain the part related to the covalent bond. As you already know, in the ionic bond, elements tend to gain or lose electron in order to achieve octet or duet stability. Then they do trade these electrons, the electrons lost by the metals are totally gained by the non-metals in order to form the ionic bond. We do come to the part of the covalent bond where atoms share electrons. It's a bond that is formed between non-metal with another non-metal. As we do previously explained, the ionic bond, it's a metal with a non-metal. Here we do have two non-metals. Non-metals, as you know, are found in group 4, 5, 6, 7, and the hydrogen, which is an exception, found in group 1. As we already know, here are the non-metals من group 4 till group 8. Actually, all the elements found in these groups, they do achieve octet or duet stability to be similar to the elements found in group 8, which are chemically stable, means having saturated outer energy levels. So here we will focus on this part, on the non-metals. The non-metals اللي هن من group 4 till 7, in addition to the hydrogen which is found in group 1, they do share electrons in order to become stable like those found in group 8. Okay? As we previously know, we have to focus on the valence or the valency of the elements. Elements in group 4, they have 4 valence electrons, so they are going to share 4 in order to achieve octet stability. Those in group 5, they have to share 3. Those in group 6, they have to share 2. And those in group 7, they are going to share 1 to achieve octet stability. The only element that achieves duet stability is hydrogen, because it shares its only electron to achieve duet stability like helium. We do come back to the types of the covalent bond. Actually, before going into the types, the covalent bond leads to form a molecular compound. Whereas you already know, ionic bond tends to form ionic compounds. We have 3 types of covalent bonds. We have single, double, and triple. When I'll explain these through examples, as you do see here. If I have an element chlorine, which is from group 7, it has 7 valence electrons. It's going to share its electron with another chlorine atom. This electron is going to be common for both chlorine atoms. And this electron also is going to be common for both chlorine atoms. So both of the chlorine atoms will share 1 pair of electron, and thus they have single covalent bond, which could be represented like that. A single bond. Okay? Another example. Here oxygen needs 2 electrons to become stable. So each of these oxygen atom will share 2 electrons to form a double covalent bond. For the triple covalent bond, the nitrogen have 3 valence. Okay, it will share 3 to become stable, and the other nitrogen also shares the 3 to become stable. So both together they will share 3 pairs of electrons, forming triple covalent bond. We do come to an important part, how we explain the bond formation. Actually, the steps are the same as those when we do explain the bond formation of ionic bond. A given must be found in the question. This given could be the Lewis electron dot symbol of the elements, or their position in the table, especially the group or the column, or the electron configuration. Actually, any of these given would lead you to find the valence electron. And when you do know the valence electron, you can deduce the valency, which is the important point for your explanation. So when you reach the valence electron either through the Lewis or the position in the periodic table or the electron configuration, you can deduce the valence or valency, and thus you can deduce the stability and explain the formation of the bond. Some students will say that we used to know that elements of group 6 and 7, they are included in the ionic bond. So how do we differentiate if these elements are going to form an ionic bond or a covalent bond? Actually, you do know. Is this element involved with a metal? If it is involved with a metal, then it's going to form an ionic bond. If it is involved with a non-metal, يعني an element of a group 4, 5, or 7, or another element of its group, then it is involved with another non-metal. So it's definitely a covalent bond. So in the covalent bond, you have to focus that it is a bond formed by sharing pairs of electrons between non-metal elements. Shared electrons are attracted to the nuclei of both atoms so that each atom becomes stable on the outer energy level. This is an example about the one we have already explained. So here I have an electron and an electron. Those two electrons, they get attracted or they get shared between the atoms. Thus they form a single one pair of electrons. You know the term pair means two. One pair of electrons, forming then a single covalent bond. Here I have carbon and 2 oxygen atoms. The carbon will share 2 pairs with the first oxygen and 2 pairs with the second oxygen. You see, 2 pairs with the first, 2 pairs with the second oxygen. So I do have double covalent bond. Now we will solve an application concerning the formation of a covalent bond. We will take a very simple example, the hydrogen gas. Okay? Hydrogen gas, as you know, the hydrogen belongs to group 1. Group 1 means they have 1 valence electron. So Lewis is like this. Okay? As you see, you are given the molecular formula. Always you are going to be given the molecular formula so as to know the number of atoms of each element. Once you do see that, you already know that it has 1 valence electron due to its position in group 1. In group 1, then you do know the Lewis. The advice is to start with the Lewis electron dot structure. Means it's 2 hydrogen. This is the first hydrogen. And this is second hydrogen. It's very clear that they are going to form a single covalent bond by sharing only one pair of electrons. Okay? So I do say each of the two H atoms, each H has one valence electron. It needs, please pay attention. Here you should say needs, because in the ionic compound we do say it loses or it gains. Here we must say it needs one electron to achieve duet stability. You can say it shares, but I prefer to say here needs. I'll tell you why now. Okay? So I've described the stability similar as we used to do in the ionic compound. We do explain the stability of the atom. Then I say the two H atoms share one pair of electrons. If you never said these two terms, you'll never get a grade. So, share one pair. That's why I told you to use here need and not share, so as not to get mixed between both terms. If you are able to differentiate, I have no problem using share here. You can also use it. So they are going to share one pair. Here I have two electrons forming one pair only. So I'll have a single covalent bond of the molecular compound who H2, or you can say hydrogen gas. We also write Lewis electron dot structure, structural formula, molecular formula. In the Lewis, we do only show the bond and the Lewis. If it has other Lewis, you should put them all the Lewis, including the bond between the shared one. In the structural formula, you only show the bond without any other Lewis. Molecular formula is only it shows only the atoms. Okay? Actually, similar to the explanation of the hydrogen gas, you'll have a homework, the explanation of chlorine gas, the exploration of HF compound. Thank you for paying attention and good luck.